By sketching these two graphs, determine the number of real roots of this equation here. Part B, you may assume that the equation here has a root alpha between 1 and 2. The occurrence relationship here with x0 equals 1.4 can be used to find alpha. Find and record the values of x1 through to x4. Write down the value of x4 correct to 4 dp and prove this is the value of alpha correct to 4 decimal places. So I've summarized the question above. So we'll do the sketch first. I won't do much of a sketch here. I'll just do a quick axis. But you would use a ruler, of course, to do your sketch. Now we've got the x cubed function here, like so. And then we've got the straight line gradient minus 1 intercept 4. So it's a straight line. I'm going to do a dashed line, but you would do a complete line here. And we can see that there's just one solution, can't we? So this would be y equals x cubed. This is the straight line y equals 4 minus x. And we can see there's one solution here. Okay, so we've done that. We've sketched them both to find the number of real roots. So here, x cubed is equal to 4 minus x implies that x cubed plus x, move that over, move the 4 over as well, equals 0. So only one real root, and that's observable by the sketch here. It's positive, isn't it? So we've done part A, just one real root. Assuming this has one real root, alpha between 1 and 2, this is the recurrence relationship. With x0 is 1.4, to find alpha, find x1, 2, 3 and 4 then. So let's write down that recurrence relationship. Turn our attention to this part of the problem now then. B. So x1 is equal to 4 minus x0, which is 1.4 to the power third. Now our final answer needs to be to 4 dp, so if we work to 5 dp, hopefully we should be okay. So we've got bracket 4 minus the 1.4 to the power 1/3. And we've got 1.37507. 1.37507. There's x1, x2 then will equal 4 minus the x1, which was 1.37507 to the power third. So let's tap that in then. So this time it will be 4 minus 1.37507 equals 37945. 37945. 4, what was it? 45. So that's x2. Now we need x3 is equal to the 4 minus 1.37945 then to the power 1/3. Let's tap that in. So let's change the number again. So it's 37945. 37868. 37868. And then x4, which is the value that we want, is 4 minus the 1.37868 to 1/3 is equal to. So let's toggle back, and it's 37868 all to the power third, 1.3788, and we wanted it to 4 dp, didn't we? 3788. And that's to 4 decimal places, which is what we wanted. So we now need to show that this is the solution to 4 dp. So, and prove this is alpha to 4 dp. So we need to turn our attention to the actual equation then, which is x cubed plus x minus 4. So here, x cubed plus x minus 4 equals 0. So if we have an alpha solution is equal to 1.37885, and if alpha was equal to 1.37875, if the x value, let's put the x value here and try x. I think that's the best way to mention it. So try these values into f of x and see what we get, and see what the solution of the equation equal to 0 is. So the f of x for this value, so we've got 1.37885 cubed plus x, so it's 1 plus 1.37885 minus 4 equals very small number, positive, small. Now here, let's try this number. So we're going to put in 875 now, aren't we? Let's go back. So instead of 885, we'll put a 7 there, and toggle back here, and put a 7 here. See what we get. We get a negative, very small. So it flips sign. This function flips sign between here and here. So it crosses the axes between these two values. So the root to 4 decimal places must be, so alpha must equal 1.3788, mustn't it? And that's to 4 decimal places.